and it gets recorded and they get upset when they can't hear the question. So get the mic when you have questions. All right, g'day guys. Welcome to the August .NET user group. Tonight we have a special guest down from Brisbane, Brendan Richards, and he's going to be doing the news tonight, and then he's going to be doing a session on clean code with Entity Framework. I assume everybody likes getting data, so he's going to show you the better way of grabbing data. Obviously, Brendan is in charge of a lot of enterprise large projects where he has a decent sized team under him. He does projects for some of the largest insurance companies, and also I went to Norway a month ago and then went and visited one of his clients in Germany, and they're extremely happy with how he's running that project, so he'll be sharing some of that stuff. This is the Sydney .NET user group. We've been running for about 20-something years. Every month we do it and we put it up on SSW TV. How many people here have seen SSW TV? Okay, so over half of you. The rest of you should check it out and subscribe. I just noticed just now that Google have now listing the events underneath companies. So it goes to show you how strong Meetup has got. It is so strong, even Google is taking notice of them. So this is us. You can, I guess we're the sponsors of the group. We run a number of different events in this space and in the Brisbane office, which is similar, and the Melbourne office. You can see the events on the right-hand side. But I guess the primary, the beautiful event is the best .NET conference or a developer conference outside Microsoft's Build and Ignite conferences, is one that comes from Norway, and it's called NDC. I have met a few IT managers in Sydney who thought that stood for National Developer Conference, so I do find that funny. But yes, it comes from Norway, and they bring the best speakers from Europe and America. It's really awesome. A few of us are there. I'm there. You're there.
I'm there. Yeah.
Yeah. A few other SSW guys. Anyway, you got super guys, Billy, and yeah. So it's a great event. Anyone considering going? Oh, wow! Over half the room. Wow, that's awesome. Now, we have a few free things that we run on Saturdays. One is called an Angular Hack Day. It's for getting up and running on Angular. We have another one called a .NET Core Hack Day. And we have a Xamarin Hack Day for mobile developers. And we have another Hack Day coming soon, very soon. The material is being built for it at the moment.
Are you going to do a Blazor Hack Day?
Are we going to do a Blazor Hack Day? I don't think so. I know that Brendan would like to do it. It's been mentioned. Yes. I think a few of us have been Silverlighted. So,
God, yes.
but I shouldn't. Yes, including you.
Oh,
yes.
well then.
So, no, look, all jokes aside, it's an extremely important technology. It's a beautiful developer technology. There is absolutely no reason why we shouldn't do it. We're just waiting to see adoption, because we care to see how developers, like the only reason it's not going to succeed is psychological issues with developers, because technically it's a beautiful piece of technology, and Steve Sanderson and others talk about it at NDC. We'll see how it rolls out. It's very early days. It's not a public beta at the moment, you know. It is one step before that. Yeah. So we also have the Angular Superpowers. That's a one-day course. If you ask me, extremely good value, heaps of good. It's $99, and you get the best trainers that do this. The only downside is one of them has a French accent, but other than that, it's great, and lots of people have got going on that. We also have a few others like this, one-day style. which is the Azure Superpowers. That has an amazing speaker that does that one.
Oh, right.
Yes.
Yeah, William's awesome.
Yeah. Cute. And we have another one called .NET Core. And the .NET Core Superpowers is done by Brendan and Jason. Jason did a video on clean coding, which underpins a number of the parts that you learn in this day. He almost became a rock star in just our little industry. He got, it's the #1 video on SSW TV. It's a super long video. Like, we have heaps of short videos which should get the long views, but his one is an hour and a half or so, and it's incredible. It's not very old. It's over 100,000 views, and it beat my Power BI one, which is years and years old, and that was really popular. So anyway, that's the story. Any questions for me before I hand over and we'll do the news? Awesome. I'll hand over to you, sir.
Okay, thank you, Adam. So we've got a bit of news this week. I was helped out by Grant from SSW Canberra, who's very keen on sharing some news around. So welcome to the August user group. So the first bit of news, and for me the biggest bit of news that I've got to share, is the upcoming release of .NET Core 3. That's great because it also means all the things I'm showing you today with the EF Core 3. That will be actually in production and ready to go. The current date is scheduled for September. They've just dropped a preview 8, I believe, and so there's no reason not to believe that's on track. So that'll be possibly released before the next meetup. So that's very exciting stuff. And for those who don't know, the .NET Core 3 is really reunifying a whole bunch of stuff that had to be dropped away to the side for a little while to make .NET Core, because we needed to make .NET Core good first and foremost for web applications, because that's where we needed to get stuff working. Applications for the cloud, Azure needed to compete. So the focus really was getting those web workloads fast and cross-platform and deployable to cloud infrastructure. Now with .NET Core 3, we're seeing much more of the windowing toolkits coming in. But what that doesn't mean is you'll get all the amazing window toolkits like WPF for Linux straight away. I know of no plans to port that, but things like Mono exist, and they're no longer living in this "are we okay" kind of mode where they first started off. They're officially, part of the Microsoft fold, and so I see no reason why we won't start seeing windowing systems and versions of system.drawing moving to cross-platform as well. And then eventually, the long-term plan is here, .NET Core 5, .NET 5, where that .NET Core and .NET will once again be reunified. Whether that will be a massive reunification process of bringing the APIs back together, or whether it will be slapping a number 5 badge on .NET Core remains to be seen. But it is a future where we're going to reunify everything. Anyone here see JK's talk last month on machine learning? One of you, a couple of you. It's a fantastic talk. Well, JK talked about machine learning with ML.NET. To give you some background, there's a few ways of doing machine learning code. One of them is to use all kinds of the Azure services like image recognition, and there's a whole bunch of paid-for services out there. But sometimes you want to deploy machine learning systems in a contained environment that isn't using the cloud. And ML.NET is a library that lets you do that. So it's a library for .NET, it's open source, you install into C#, and you can start doing things like neural networks. And that's now on 1.2, it's improving, and it's a way of doing some of those exciting neural network type machine learning things directly in .NET in your own code. Another thing that's quite exciting here, new development, is improved support for WSL, Windows Subsystem for Linux, for Visual Studio Code. So Windows Subsystem for Linux lets you basically installs a kind of kernel level driver that does the work of the Linux kernel. So it's called Windows Subsystem for Linux. It doesn't actually include a Linux kernel. It includes a byte compatible low level thing that does what the kernel does, the Linux kernel. But then you can run Linux packages on top, and it's binary compatible, so you can install Ubuntu or SUSE or Fedora, and that just runs on top of this layer inside a window on your machine. So with that, you can run all the tools you get from Linux. So the plugin for Visual Studio Code lets you open up Visual Studio Code and mount that Windows subsystem for Linux like any other file system. So you can actually be opening up files in Linux and editing them directly from Visual Studio Code in Windows. So it's a really good development story. It means you can develop full Linux with binary compatible Linux without having to install Linux and without having to compromise on your tooling, because you just open up Visual Studio Code right there in your computer. So that's fantastic. My final piece of news to share with you is some improved docs. So Microsoft have now got docs.microsoft.com/samples, and this is a global place for all samples across Microsoft. So all the various documentations used to have samples attached to it. Now there's one place to put all their sample code for all their things. So it's a great resource. And I found over the recent years, the quality of Microsoft documentation has just skyrocketed through the roof. It's open, it's searchable, it's really fast, and the amount and quantity and quality of that content is amazing. It's never been better. So check that out. And before I move forward, it's a quick question if anyone's got any news they'd like to share happening in their area. Okay, let's move on with the talk. That's the wrong one. That's the right one. So welcome to my talk, Clean Code with Entity Framework Core. And so the real focus of this talk is to introduce you to Entity Framework Core. Everyone's got different levels of experience with Entity Framework in general, but then taking the core concepts of Entity Framework Core and looking at how we then use those within a clean code architecture. So to introduce myself, my name is Brendan, and I'm a solution architect at SSW. And that means I spend most of my time at client work building websites of various kinds, various sizes, various scales. So most of my time is spent doing this stuff for production. But now and then I get to kind of take a break from that and do a bit of teaching. I do the user groups like I am now. I do some hack days and the training, the superpowers tours. And they're fantastic for really cementing kind of your knowledge. It really helps if you want to kind of learn something, explain it to somebody else. It really helps you get your thoughts in order. In a previous life, though, way before I moved to Australia, I was a Java developer. And when I was a Java developer, I had some cool things. And around about 2003, one of the cool things we had in the Java world was called an ORM. The first one I had was called the Object Relational Bridge. And then a little bit later, I started using something called Hibernate. And the idea of those was data libraries to talk to a database, which I'll cover in more detail. And then over time, in 2004, I moved to Australia. And I found myself in a place where there seemed to be much more .NET work about than there was Java work. So I started doing .NET development. But I found that I missed a lot of my libraries. And I found that when I looked at the standard Microsoft stuff, no one was talking about dependency injection. And no one was using ORMs or open source loggers. So I started looking around and I'd find things on the internet where people had taken Java packages and ported them across to .NET. And it worked quite well because there was a huge equivalence between Java and .NET back in those days. And so I started finding libraries like nlog and nant and nhibernate that did the work for me. And then later on, Entity Framework came out and I started using that instead. And over time, Entity Framework pretty much replaced Hibernate in the ORM space. Finally coming to now, where we've got the latest version of .NET Core about to be released. I'm going to talk about a few things today. I'm going to start by introducing Entity Framework Core and some really key fundamental things that even if you've seen it before, it's worth going over, because based on my experience, I see various usage patterns used in the wild that I want to try and stamp out. I want to try and get people to understand how it's working behind the scenes, and therefore what is the best way to use Entity Framework. I'm going to cover the basic usage, and then I'm going to take a step back and start looking at clean architecture, and then how we can fit clean architecture or fit Entity Framework Core into a clean architecture setup. And then I'm going to very briefly cover testing, EF Core performance, and finally I'm going to cover what's new in the latest features of Entity Framework Core 3. So let's start by introducing Entity Framework Core. This is the blurb straight from the Entity Framework Core homepage, And it says, Entity Framework Core is a lightweight, extensible, open source and cross-platform version of the popular Entity Framework data access technology. Doesn't tell you much there. It says Entity Framework is a version of Entity Framework. But the next line does tell you a bit more. It says Entity Framework can serve as an Object Relational Mapper, ORM. So I'm going to start by highlighting that sentence, those words, Object Relational Mapper, and start talking about what that means. So an Object Relational Mapper, or ORM, was created to solve what has been called the impedance mismatch. And the impedance mismatch is all about differences between how a database handles data and how an object-oriented programming language handles data. So let's take a look at a database. If I want to put something in a database, I first have to create something called a table. And in that table, I'll create columns. And each column has a name and a data type. Then if I want to put data in that table, I just fill in those values. I've created a table there of people. If I want to take some more data and make it related to that data, what I can do is I can create a second table, fill that with values. And if I want to link the green table back to the grey table, what I do is I create what's called a foreign key. So there's a value in the second table that matches the primary key value in the first table. And that creates what's called a one-to-one relationship. One record in the green table matches or links up to one record in the grey table. If we want to make this a many-to-many relationship, I can make sure there's no unique key on the foreign key there, and allow duplicates in there. I can now link two skills to my people table. If I want to make a many-to-many relationship, though, I can't do it with this pattern. What I have to do is put a relationship table in the middle. So this blue table in the middle is composed just of foreign keys, and it links between the two. So I can have many people with many skills, and it's a true kind of relationship table. Now in Entity Framework 6, you could point a system at the Entity Framework, and it would generate this middle table for you. Now Entity Framework Core still can't do this, but sometimes I find that's not too much of a drag, because quite often when I'm building software, I want to put some kind of auditing against this data. So who created it and what time they created it. If I have an auto-generated table with just foreign keys in the middle, I can't tell who linked these two things together and when did they do that. So quite often I'll actually deliberately put a middle entity in the middle just to handle that relationship mapping. So let's take a look at what happens when we start talking about object-oriented code. So in object-oriented code, you have this concept of an object. An object can contain data plus behavior. So I've created two classes here, person and skill, that basically match the data types you've seen in the previous database. But if I want to link person to a skill, I can just put a reference there, because I've got in-memory reference pointers. And if I want to make it a bidirectional relationship, I can put a reference on either side, or put references in both directions, so that the person knows what skill it has, and the skill knows what person it belongs to. If I want to make a one-to-many relationship, I can use a collection. Then optionally, I can put a corresponding reverse relationship going back, or leave it out. Or from many-to-many, I can create a link each side. So all in all, when you're talking object-oriented code, it's richer than what you can do with just databases, because databases are just columns and tables of data. With object-oriented code, you have data plus behavior. In object-oriented code, you have classes, inheritance, polymorphism, and encapsulation. And you have pointers and collections that can model relationships. So overall, object-oriented code gives you a much richer toolkit for modeling data. So we've talked about the impedance mismatch and how Entity Framework works to manage that. Let's now start by looking at some of the core features of Entity Framework. And the first thing to talk about is the core class called the DB context. So the DB context is the most important class in Entity Framework. It's kind of the root thing you create to start working with your data. And it's your interface to data via another class called the DB set. The DB context, this is the most important thing, acts as a unit of work and tracks changes to the entities that have been loaded into that DB context. And we'll cover that in more detail a little bit later. It's also quite smart. It can sort out all the relationships between the entities you've put into that DB context. So it works out what's new, what's changed, what links to what, which foreign keys have to be replaced, and does quite a few things for you. And it sorts it all out when you save at the end. It's also really important to manage the life cycle of your DB context. Because the DB context tracks changes to the data you're working with, it uses memory to do so. If you have a DB context that lives too long, it's going to start filling up with more and more memory until your entire database is there in memory. Now, if you're working with a .NET Core web application, that's really easy to manage because all web applications are naturally bounded by that request. You have a request coming in from the web, it kicks off a process to handle that request and finishes at the end. So generally, you'll work with a DB context with a context per request pattern. And that's the default pattern you get when you plug Entity Framework into your web components. So let's take a closer look at Entity Framework and how it tracks changes to data via various entity states. So I've created a few boxes here. One's the database, and one's this big box called the DB context, and inside it are a bunch of entities. And by entities, I mean these are plain C# classes that have been loaded from the database and hydrated by Entity Framework, and they're kept inside the DB context. So the first and most simple thing I can do is I can say dbset.add. And what this does, I'll do this with a new class. So in my code, I can type new customer, and that will create a customer object. I can feed in properties of that customer object, and then I can say, okay, DB context, take this object and put it in the added state. So what happens there is DB context accepts that, it keeps that entity in the added state, and then if later on I hit save changes, it will fire a database insert. The key thing here is no database work happens when I say dbset.add. It all waits until later when I call that save. The next state to talk about is unchanged. So this happens when I load a database, I load an object from the database, it gets put in the DB context, but I haven't touched it, I've made no changes to it, so it's now in the unchanged state. This happens if I do dbset.where and load a bunch of records with matching a predicate case, or dbset.find to load them by ID. dbset.find is useful because it will also cache results. If it's already in the DB context, if you go and find it by ID and it knows it's already got it there, it won't bother touching the database to get that object for you. The entity state.modified, this is what happens when I've loaded a customer from the database and I've got that object. If I then in any way touch that customer object, so go customer.name equals and then change the value, the DB context intercepts that operation, knows it's changed, and marks it as modified. So all I need to do to change data is modify it and then save changes later. The DB context knows that I've changed it, and it tracks those changes for me. The entity state detach is quite interesting here, because this is what happens when I load an object, I put it in the DB context, I keep hold of that object, but for some reason I close the DB context behind that object. So now in this state, I've still got that object. I can still look at that customer, I can read that customer's properties, I can modify that customer's properties, but it's no longer attached to a DB context, so it no longer knows, has that path back to the database. There's another feature of Entity Framework that was on by default in Entity Framework 6 and is available as an option in Entity Framework Core, and that's a feature called lazy loading. So lazy loading is all about managing relationships between objects where, say I've got an order and that order has a list of order items, I can load the order but not load the order items yet. What will happen is the DB context with lazy loading turned on will monitor my use of that object. If at any time I go order.items in my code, it'll intercept that operation and say, okay, you haven't got that yet, but I will for you go and fetch that data behind the scenes with an extra database query. So it's really useful for situations where you've got a few layers in your application, you've got a custom bit, a central bit of code that fetches things, and you pass that down to the next layer and don't know what the next layer is going to do with it, because then on the fly it will load that data for you. But it's really bad for situations where you're rendering out a whole table of data, because you might end up with what's called the n+1 problem. Say I want to display a table of 50 orders, and I want to also display information about those order items. I will make 51 database requests, because I have one request to fetch the original list of orders, and for every row, I'm going to throw a second request to get the order items. So it's called n+1, one to get the data, and one extra one to iterate through the things. So what you can do there is you can tell Entity Framework to preload those orders, or you can turn lazy loading off and actually manage that by hand. So lazy loading used to be on by default in Entity Framework 6. That made it controversial because there was lots of code being written by people that was inefficient, loading far too much stuff into memory. So now it's off by default, which is much safer, but you now have the option to turn that on. So coming back to this diagram, we've got a detached entity. So what do I do to get that back in place? Well, what I can do is use what I consider to be the most misunderstood command in Entity Framework. It's called update. The problem with the word update is also the name of a database operation that you want to do if you want to update data. So naturally, a lot of people see this thing called update on the DB set, and they assume that means I need to call that every single time I want to update my data. But that's not the case. What update is for taking a detached entity, putting it in the DB context, and marking it as in the change state. If I have an entity that's always been in the DB context and the context was never closed, it's tracking the changes. I don't need to tell Entity Framework that it's changed. In fact, if I call update, I'm going to tell Entity Framework that the whole object is dirty, where potentially Entity Framework has the capability to only update the fields that have changed. So if I use the update command when I don't need to, I'm going to do more database work than I should. So the update command is specifically for taking a detached object, put it in the DB context, and calling it and marking it as modified. And in fact, Hibernate and then Hibernate went through a whole round of this exact process where they had an operation called update, and they realized it was misleading, so they changed it to merge later on. But Entity Framework never went through that, that process yet. And finally, at the very end, I can call save changes. And save changes is a powerful operation.
Can I just, yes, could you just quickly rehash what you just said again, just quickly summarize it again for me?
About using the update command?
Yeah, how did I get my data that is detached? Is that, so I did a query I did 5 minutes ago, and I've kept it in memory?
Yes, so maybe if you, for example, put an object into memory cache, close the DB context because the request is finished, but pull it out of memory cache in another request, and then try and work with it, is now detached from its DB context.
So that would be the sort of thing I'd typically do with my reference data, but if I then decided that I needed to update some of that reference data, I would just update, if I wanted to update it in the database, I would need to make the change to it. I'd need to call update,
yes,
and then I'd need to call save.
That's right, yes. Yes. So in the case you do have a detached entity, like it's come from memory cache and the DB context because it was in a different request that was loaded, then you can just, that's the right time to use update. That will then put it back in the new DB context, and you can carry on working from that point.
Thank you.
No problem. So finally, save changes comes in. And save changes is the kind of a pretty powerful thing because, like I've said before, it works out a whole bunch of details about what's related to what and who owns who and which things need to be created, which things already exist. And things like I can create a new object, but that could have a reference to something else that already exists in the database. It'll work that out and know that the reference is just a reference to an existing thing and not a reference to another new thing. And it kind of does all that work for you, so it's smart. So any questions before I move on real basic concepts of Entity Framework? I'll move forward and we'll cover some basic usage. So this is the default 101. How do I go about using this engine? So we've covered the engine and how it works a little bit. Let's talk about how we use it. And how we use it is really quite simple. First off, I'm going to show you some code. This code is on GitHub. That's the GitHub URL for it. But this code is borrowed heavily, if not blatantly stolen, from some other code made by Jason Taylor called Northwind Traders. The idea of Northwind Traders is we took the classic Northwind database, which was a sample database made for Access, and it was made in the kind of mid-90s. Basically just scaffolded up a whole bunch of code and a whole bunch of initializers so that we can create on the fly a database application hooked up to Entity Framework Core that we can use for sample applications. And I use this for pretty much all my sample code these days because I can get a known working, a database that's easy to understand. It's got customers, it's got products, it's got orders and order items, all the things that are really easy to explain, and it's got a database full of data that you can queries against, so it's really useful. So what I've done is I've taken that, I've hacked it around a bit, upgraded various bits, and tried a few things out here. So I did a kind of copy rather than a fork because I wanted to really highlight certain features of Entity Framework that don't actually match or belong in a sample application. Like I'll show you the wrong way to do something and leave that in there so you can highlight that and then show you the right way. Well, that has no business being in Jason's perfect sample application. So the first thing to do if you want to work with Entity Framework is define some entities. In this case, it's just a plain old C# object. I've got a customer, I've got a whole bunch of fields, most of them strings, and I've got a list of orders that your customer has made. Simple stuff. Then I have to create a thing called a DB context. So a DB context is, like I said, the main class. And in that DB context, I configure what types I'm going to manage. And also I can assign some configurations. So my recommended way of doing configurations is to use this command you see at the very bottom there, apply configurations from assembly. So that will scan an assembly you give it and find all the configuration files you've put in there and pull it on at once. Because if you don't do that and you've got a big system with 100 tables, you're going to get a lot of configuration in this one DB context file. So once you've set up a DB context, you need to configure it against your .NET Core application. And the way you configure a DB context is pretty much similar to the way you configure anything in .NET Core. Because .NET Core, unlike the previous .NET, has a really good built-in abstraction for setting up dependency injection. So what that means is you've got this function here that's in startup, and startup is a kind of new file that's there in every single .NET Core web application. And it builds this thing called iService collection. And then if I want to add something to any .NET program, I just find that library, look on the first page of the library, maybe 3 or 4 lines down, they'll be say, install this NuGet package, going NuGet install or .NET add. And then they'll say, add this to your services. Because what all the libraries do is they make an extension method on top of this iService collection. And the extension method would be services.add my thing. So services.add DB context, or services.add mediator, or services.add fluent validation. All these libraries just wire themselves up. And what these functions then do is register all the types you need into dependency injection. And just to really quickly explain what I mean by dependency injection, with dependency injection you configure this thing called a container that gives you your dependencies. And your dependencies are the things you need for a piece of code to run. Like in this case, we've got some code that will require Entity Framework. Then once you've configured that stuff inside a container, like we've done here with these add commands, if I then want to use that thing from anywhere in my code, you can see the top few lines there are declaring an instance of the DB context. And you see that in order to create a scaffolded customers controller, there is a constructor there. And that constructor requires a DB context to be fed. So that means I cannot create a version of this controller class without having an instance of that context provided. So what the dependency injection system does is the framework will make sure that every time I ask the framework to give me a controller, it will wire up a DB context from configuration. The idea of doing this is an alternative to doing it this way would be I could just inside the class somewhere go new DB context dot and start working with it. But then I've tightly coupled the code I'm writing to the dependency I need to work with. So with dependency injection, instead of me saying I want to create one of these myself, I'll get the framework to provide what I need, and I'll declare what I need, hopefully as an interface, because that means I can then replace that interface with test versions and do unit testing. So one more thing you can do with Entity Framework is once you've got that set up, you can even scaffold controllers. So this is inside Visual Studio. You right click and go add, and you click controller. And then further down, you've got this really awesome looking thing called API controller with actions using entity framework. Looks awesome. So you go click on that, and that then generates you a controller based on your data in your database and based on the mappings you've made up. But I've got some problems with what you get when you do this. It works pretty well for really simple applications, but it's got some issues when you start writing bigger and bigger applications. And the problem I have with it is that right at the top of this line, so what we're looking at here is an action inside a controller. So this is the first piece of code that you write that runs when an incoming request comes in for your application. So the point of this is to receive a request from the web, probably a JSON request or a web request, and then run your code inside this action. But if I have my incoming request here, which is the top of my stack, and then my database one line down, which is the bottom of my stack, where I'm going to put my business logic, where I'm going to put my code that makes decisions or does any work, it all has to go in that one little gap, that little sandwich between those two lines. There's some other problems here in that what we're doing with this code is taking everything exactly as it is in the database and sending it straight over the wire to the client. The chances are you probably don't want to do that. You don't want to share every single piece of data in your database with everybody. So my recommendation here is as soon as you get to a little bit of complexity, you want to start thinking about not sending just the data as it is in the database straight down to the client. You want to start thinking about creating view models that are optimized for what the client's supposed to see and having data server side that is what the client's not supposed to see. There's another problem here, and that problem pops up if your database has bidirectional relationships. There's nothing wrong with having bidirectional relationships in your database. It's a really good idea because you want to start at one point and navigate around. And if I happen to know the idea of this thing here, I want to go and navigate around to the next thing over there. And where my starting point is can change around different requests. But if I have bidirectional relationships in my database, then if I try and send that customer into the JSON serializer, the JSON serializer will go crazy hopping between those two entities until the memory runs out. So once again, the recommendation here is to create a view model that doesn't have that bidirectional relationship and then just render what the client needs to have and not everything.
Question. Could you please explain what you mean by a bidirectional relationship? Are you saying a customer with orders, for example?
Yeah, so bidirectional, so I was asked what I mean by bidirectional relationship. So bidirectional relationship is when this thing has a pointer coming back to this thing, and this thing also has a pointer coming back. So coming back to my examples right early on here. Okay, so here's an example of a relationship where the skill has a link back to person. Yep, so I can get from skill to person by following that reference. But if I've got a reference to person, I can't get back to the skill. I'd have to query the whole list of skills and find the ones where that person is linked. But in this example, it's bidirectional. The person knows about the skill, and the skill knows about the person. And if I was to render that in JSON, it would start rendering the person and go, okay, here's the person, here's the ID, I'll put the ID across, put the name across, oh, I'll create a new wrapper for skill. And then I'll start filling in that nested wrapper, ID, name for the skill, and then there's another object, so I'll create one for the person. But that's a reference back, so it will basically get stuck in a loop.
You're saying it's so stupid, it's going to say, I've got skill number 123, I've got person number 456, and then say, oh, I've got a reference to both of those, I'll put those both in again, even though it's already done them.
Well, JSON by default, in the simple mode, will be dumb and just hop between them. What you can do is start hacking around with your JSON serializer and set up your JSON serializer to start tracking objects it's dealing with, and to have the JSON serializer start to unpick those bidirectional relationships. But for my money, you're much better off building the structure you want to get sent to the client and sending that explicitly. You can hack around with your JSON serializer, but then your JSON serializer is no longer just dumbly following your records. It's having to keep a whole new section of memory, keeping track of what I've looked at and what its ID is, and whether I've already seen it or not. Now, it's definitely possible to create JSON where you can create JSON where you put all your objects in one spot and then build your structure with references. But that's much more complicated JSON than just having the data arranged out in the structure it's in.
You solved the problem by saying view model earlier.
Yes, that's right. Let's take another look now. So we looked at a GET request. And we could put this back into context. We're talking about what I don't like about the default scaffolded controllers. There's nothing wrong with them. They work. But if you're going to start building bigger applications, enterprise-level applications, they're slightly problematic. They're a great demo. So, this is how it works, the easiest way of getting it working. But let's start looking at the next bit. So what we're looking at here is a put request. So I have something has fired off a web request, including some data, and I want to update a customer record, so I'm calling a put request to put that thing up here. Now I've got this object here, right at the top, of type customer, and its name is customer. And this looks a lot like it's an entity from my database, but it isn't. What this thing is the result of data binding on the web request that came in. Now I don't want to put you off your pizza that you've just eaten, but that might have come from a JavaScript application. It certainly is coming from the web, so it's not to be trusted. But right here is in this code, it looks like it's one of our entities from our database, but it's actually just been newed up by the framework from whatever junk came in over the wire. So that's problematic. And then what we're doing in this code is throwing it straight onto the database and saving it. Now obviously you've got plenty of options for wiring in validation, but it's still got problems. What if there were some missing fields in that data coming in? Well, it would just set them to null. There's another thing here that I thought was quite amusing. They're so afraid of the database db set to update command that right here they're pretending it doesn't exist. I actually like this line of code because it's far more explicit about what's going on. It's saying take this object, put it in a DB context and mark it as modified. That's what the update command does, but this is explicitly saying that rather than just calling update, which looks like you're going to call an update command, but it's not what it's doing. So I like that line of code, but again, it's a good thing to point out, and it's the key thing here, I don't like taking this object and putting it straight into the DB context. So I've had a bit of a look about what I don't like. So what do I like? So let's take a step back and take a look at clean architecture. I'm going to bring up my classic slide now. I use this slide in every talk to justify absolutely nearly everything. Because for me, the point of architecture is to avoid what's called spaghetti code. So in spaghetti code, the relations between the pieces of code are so tangled that it is nearly impossible to add or change something without unpredictably breaking something somewhere else. That certainly sounds familiar to me. Anyone seen this kind of problem? Quick show of hands. I see some nods. Yeah, everybody. That's right. No one sets out to make spaghetti code. Everyone says to themselves, right, this is a nice new project. I'm going to keep it clean this time. I'm going to have everything set up just right and everything properly. And then requirements change, don't they? And now because requirements have changed halfway through the project, you've got far less time to build it. And so you'll make a shortcut or you'll pluck something where it doesn't do, and then you've got to just make it work. And suddenly you've got all this stuff that's interconnected, and you end up with this spaghetti code system. It just naturally occurs. So for me, the secret sauce of spaghetti code is dependencies. You get spaghetti code when you have code in one place that's used by two different places, and you change it once to make that thing work, but then you've broken that thing over there. And so for really the best way of managing spaghetti code is to carefully manage your dependencies. And that's where clean architecture comes in, because clean architecture is all about managing those dependencies. So clean architecture is known as a domain-centric architecture, because in the middle you put this thing called the domain. And so the domain is all about modeling the problems you've got to solve in your application. So in the case of Northwind, we've got objects like customers, we've got objects like orders, we've got objects like order items. And the relationships between those objects are true regardless of what you're doing with those objects. So a customer can place orders regardless of whether or not I'm using a SQL database to store it or whether I'm just running it to a file somewhere. That truth about customers and orders is universal regardless of the technology I'm going to use to save it and get it back later. So the rule of thumb here is we make the domain as complicated as we can with as much business logic as we like, so long as we don't take on dependencies to any external libraries or applications. So model the raw data as much as you can. And the good thing about Entity Framework Core is it's getting better at dealing with more complex domain objects, and I'll cover some of those features later. Then around the domain, we have this layer called the application. So you can vary this quite a bit. I've seen some people do clean architecture where they just put application domain all together, and that's, for a smaller project, that's fine. But the idea of application for me is really about the operations you can do. What are we actually going to do with this data? So it's the interface to actually go and create an order for our customer. So you see this grey arrow here. Well, this grey arrow is the dependency. So the application layer knows about the domain and knows we're dealing with customers, but the domain doesn't know about the application layer. It's just modeling that core data. Then on the outside, and I always bring these up together, are infrastructure. So infrastructure are services we need to actually then do this work. So for example, I might need to send an email. I don't need to know that I'm going to send an email later in order to model that a customer has orders, but at some point in the application, I'm going to want to send an email saying, yep, you've replaced your order. So to do that, I need to have an email sending service. And the idea is that I put an interface about the email sending service in the application, but the actual infrastructure that sends an email is then an implementation of the interface, so the application doesn't know the details about how that's sent. So I might be sending a message via SendGrid one week, and I might decide to switch to SMS another week. If I make the interface generic enough, I can swap these things out. And so with infrastructure, we also have persistence. So like I said before, the fact that it's going to a database or it's going to an XML file shouldn't affect the application too much. But if we can make our persistence as a separate process, and with that dependency flowing inwards, then we've decoupled our application a bit more. We've got things that we can test in isolation away from all the infrastructure that helps them to work. And then finally at the top, we've got this thing called the presentational layer. And in all the demos I'm showing you today, the presentational layer is just the network traffic layer. It's taking requests in from the web, from a JavaScript application somewhere, and just pushing them in to the application. So to recap on the clean architecture, it's all about managing your dependencies. Got a question?
Could that just as readily be a Windows Forms application? It doesn't have to be a web application. That model would work just as much, I'm assuming.
Yes, that's a very good point. This design is a pure design that applies to any application. Like you could take this on for a Windows application, you could take this on for anything you want to build. Some of the details might change, obviously, but you could apply this to any language and any application you want to build. It's just a way of laying it out. Or you could choose a different pattern, but this is a great pattern to kind of work with and build an application. So yes. So we started off with managing your dependencies. It's also highly testable. The whole point of managing these dependencies is we can look at bits of the domain or the application layer in isolation and run unit tests with them. Disconnect them from the database and make sure they still work, and make fast tests that work that way. It's also independent of the user interface, independent of the database, and independent of anything external. If you think you've seen this stuff before, it looks a bit like onion architecture. It's pretty much the same thing with a new badge. I consider onion architecture and clean architecture, certainly at the high level I'm showing it here, to be pretty much the same thing. So when we talk about this type of architecture, and we talk about the persistence layer, we've got to start discussing what interface do we use between these levels. What interface do we put between the application and the persistence layer? And for a long time, across the history of onion architecture, and for a lot of people still, that has had one answer, and that answer has been something called the repository pattern. So the repository pattern mediates between the domain and data mapping layers, acting like an in-memory domain object collection. Now the repository pattern is one of the most widely used and widely understood patterns going. A quick show of hands, who's at some point or other written a repository pattern? A few of you? Who's written a repository pattern and then really closely stuck to this, it's a domain it acts like a collection in memory. Who's done it, but then found it started to grow over time and have more and more features until over time it became the de facto application layer. And all the business logic in that whole application was there inside the repository. It's supposed to just map between your business logic and your database, but actually became your business logic. Certainly happened to me. So I'm not trying to comprehensively knock the repository pattern. It is a good pattern. I have used it well, and I've actually written libraries based on the repository pattern. But here's a question here. Do we still need to implement these patterns when we're dealing with Entity Framework? Well, certainly Entity Framework Core insulates your code to a point from database changes. In Entity Framework 6, you couldn't answer this, you couldn't claim this very well, because the only good database provider for Entity Framework 6 was SQL Server. So you could tie yourself down to SQL Server, which, you know, probably a good thing to do. No one ever actually changes their database. I've done it, I think, in one project in my life. So just take that dependency and work with it. But now with EF Core, you've got much better database providers. And Postgres, which is my favorite database, is the top level provider by default. It's, you know, it's kept up there side by side. It is fantastic. It works really well. And actually, one more thing, I haven't got time to show you today, but in that sample code I actually made a version of Northwind where I created 2 persistence layers so that I could use either Microsoft SQL Server or Postgres and actually manage both of them. So I had one DB context and one DB context configuration, but created 2 sets of migration changes. So the schema changes were specifically for the 2 different databases, but the actual configuration, the layer up, was the same, and I could use both databases and, you know, switch them at runtime. So check out the code base to see that. So the DB context acts as a unit of work. So the idea of the unit of work is when you're dealing with repositories, you're dealing with something that looks like a collection. You see, add stuff to the collection and remove stuff to the collection. But when you're dealing with databases, they have the concept of a transaction. So if you're just talking to repositories that act like a collection, I could talk to the customer collection, I can talk to the order collection, but there's nothing naturally there that wraps them up into a one package. So here's an event where I've created a customer, and then they're a new customer with a new order, and let's wrap that all up into one transaction. So unit of work is that conceptual pattern there to map changes across multiple repositories into one unit, which then maps to a database transaction behind the scenes. Well, the DB context acts like that. And the DB set acts like a repository. It's got all those actions you expect to see on a repository layer. It's got add, update, those kind of things. And finally, EF Core has features for unit testing without repositories. So if unit testing is your main reason for using repositories, then unit testing fills that in as well. Now, I'd like to say again, I'm not saying don't use repositories. What I want to say is you've got a choice. You don't have to, and do what works best for you. So we've talked about the repository pattern, so what should we do instead? And what I'm going to talk to you now is about a slightly different pattern, and I'm going to advocate for putting that pattern not at this layer here in the arrow between persistence and application, but actually take some concepts a little bit higher up and do a little bit more work in our application layer first before we have to talk about our database. And the bit of work I'm going to put inside the application layer is called CQRS. Do you have a question? You pass across the thing.
So as for the previous slide, just wondering, I don't know too much about Postgres, so let's say SQL Server. Does it wrap the whole unit of work in a transaction? And also, what sort of isolation level does it run under on the EF Core by default?
Yeah, it's a good question. I'll repeat the question there. So the unit of work does support transactions. By default, a save changes is a transaction. It has the default isolation level with that transaction, which I believe is read committed. Yeah, I think it's read committed. But you also have support in Entity Framework for adding a transaction scope around it and setting whatever transaction scope you want. So if you want to do work across multiple instances of a DB context, for example, and I have done this before when I've got a lot of processing to do, maybe I'm processing a big batch of records, because the DB context can fill up, one good way of processing is do 1,000 records at a time, save, drop the context, bring it up. You want all that inside a transaction, then you can put a transaction scope around it, and that just uses that context-based transaction scope thing. Now I know that context-based transaction scope thing is very hard to get working with async code because it does use things like thread local context, and you have to have code that's able to refer back to a magic context somewhere so it knows that context is there. And I know async code can mess with that a little bit. You have a question? Yeah, grab the mic, please.
Sorry, so the solution that I've implemented for that is to create some middleware on the request pipeline that has the DB context injected, and you start and end the transaction on between the begin and the end of the request. Yep,
so that's a good way. Yeah, so you can certainly wrap a request. You can wrap a request in a transaction at the beginning and end, or you can create your own scopes. One thing with dependency injection is you have this concept of a scoped object. So if you're working outside of a request, or you want to actually make your own scope inside a request, just go and do so. Create a new scope, and then anything inside that scope will have that life cycle and get disposed of and finished off when that one scope is finished. So you've got some very good APIs for dealing with that now that weren't there by default. You'd had them if you took on certain dependencies, like if you're wired in AutoFac, if you're wired in Unity, which was the Microsoft one. But now you've got a really good default implementation that gives you these concepts, and you're also still free to pull in things like AutoFac and get a much more richer configuration system, and that works transparently with the kind of default APIs and adding AutoFac on top. So you've got a lot more options there, going back and forward. So let's talk about CQRS. And what I'm going to advocate here is taking a step back from the database layer and start putting CQRS as a concept inside our application layer. So what do I mean by CQRS? Well, CQRS stands for Commands, Query, Responsibility, Segregation. So the idea is that you split off your commands, which your database writes, from your reads. And there's some good reasons for doing that, because lots of applications are quite read heavy, and there are different things you want from reads versus writes. In most cases, you want your reads to be as fast as possible, and you want your writes to be as correct as possible, because if you've written the wrong data, it's a catastrophe, but your reads, you just want to make sure they're fast. And so there are a number of ways of achieving this, but we're going to start with the simplest possible way, just by having one database, but acting differently between doing queries against the database and doing writes against the database. So like I say, you separate reads from writes, and you also take on this thing called the single responsibility principle. So for me, there are kind of two almost competing concepts here. Don't repeat yourself means that you want to write something once and reuse it as much as possible, because don't reinvent the wheel. But the single responsibility principle is more about managing that dependency. Sometimes you're better off writing two different versions of the thing, because then changing this one won't break that code over there. So the single responsibility principle is all about making something contained that does a very well-defined job, and reuse it as many times as that well-defined job. But what you should never do is start tweaking that well-defined job to act in multiple use cases, because that's when you get that dependency hell of stuff that breaks and having knock-on effects and side effects. So with CQRS, it's easy to add new features, just add a new query or command, and it's easy to maintain because your changes only affect one command or query. And CQRS pattern can be used with repositories. This is not replacing it, this is something else to do a step above, and we'll look at that in more detail a bit later. So CQRS can be quite a loaded term. It can mean quite a number of different things to different people. There are a bunch of different ways of doing CQRS. For some people, they equate CQRS with event sourcing. Now, event sourcing is a kind of next level way of doing your data in your application. By all means, use it if you need to, but you don't have to. What event sourcing is all about is it's really useful for really, really high throughput work. So with event sourcing, instead of keeping the database in its natural third normal form state, and when work comes in, at the end of any piece of work, we end up with the database once again in its pure third normal form state, and we do it all in a transaction, and we make sure we do everything one at a time. Instead, with event sourcing, instead of modifying the database as things happen, what we do is we take a record of the event that happened. So let me think of an example, and that's once a year they sell Splendor in the Grass tickets. Now what used to happen is those tickets would go on sale, and 100,000 people would log on that instant and try and buy a ticket. And when that was plugged into a transactional database, that would start turning hot, then start smoking, and it would fall over, and no one would buy any tickets. And it was always an embarrassment. But when you're talking, so let's have a think about the data you need to know about selling tickets. So a traditional transactional system would take someone's order in, write that to the database, update 3 or 4 tables. Here's the order table, here's the tickets table, there's a ticket in there's orders in the database, order items. And so there's huge contention on the order items table because they're being written to all the time. But someone that wants to buy a ticket doesn't need to know about all those records in the order items table. All you need to know to sell a ticket is one integer. That's how many tickets are left. So instead of waiting for all this stuff to come in and then applying it all to the database and doing it really slowly because it's writing data, instead, what you do is you have a single data store that's called the event store, and that event store is the things that have happened. I have sold a ticket, bang, goes in. I have sold a ticket, bang, goes in. And then as those tickets are processed, the first thing you do is just look at that ticket, look at how many tickets were on it, or that order, and you just subtract 1 from that integer. So that integer is what we call a read model. It's not a permanent store for that data. It's just a number that represents it exists just for reading, because the next one coming in doesn't need to query the database and query how many have been sold. It needs to look at one number in memory and says how many tickets are left. So then later on, and you've got all the time in the world, you can process those orders. And so you'll process those orders, then push them into the database. But I've been able to sell these tickets because I've got this backlog of orders to process. And that's where the idea of eventual consistency comes in. So instead of having the database transaction come in and we apply it to the database and wait for that to resolve itself, we take the events, we store the events, and then in our own time, we process those and finally make the database consistent with what we need it in the end. So eventual consistency. Now what might happen in that situation is you might accidentally sell 5 too many tickets. So what you do in that situation is you have a business process, because we've just sold 100,000 tickets, so we can afford to have one person sat there on the phone and phone those 3 people up and say sorry. But what you can't afford to do is have the whole thing fall over and sell no tickets. So it's a situation where being 100% atomically correct isn't serving the business any purpose at all, where being able to take in a huge load in one go is much better. So that's the idea of event sourcing. And the key idea of event sourcing is this store of events and this read model in the middle. So that's something that's available to you if you start going down the CQRS route, but that's not what CQRS is. CQRS can be much simpler than that, but CQRS allows you to take that thing on the go. And it also doesn't necessarily mean separate data stores for reads and writes. What it does mean is clearly separate commands and query operations and separating your processes for reads and writes. Do you have a question?
Yeah, just a very simple one. I think what the thing you've left out of that, and I agree with everything you've said, by the way, it's a really sensible model, is what if your server crashes, you've got to have a restart process, and that means that you've got to look through that entire event table to work out where that number is when you restart.
That's right,
so
yes.
Your restart is still going to be relatively slow, but it's still going to be blindingly faster than the alternative.
Well, that's right. You're faster, but there are a whole bunch of, when you're talking that kind of disaster recovery in an event sourcing model, there's a bunch of processes. Maybe you don't want to spend too long with a backlog of events, but as you do process those events, you can at any time create snapshots of the data store at that point in time. And once you've created that snapshot, you no longer keep that whole backlog of events. You can throw those away, unless maybe sometimes what you can do is do a wicked undo process where you roll back to a snapshot point in time, apply events, but choose to take some out because they turned out to be invalid. And then you can actually roll back time against your database. So there's some really powerful things become available to you from event sourcing. But this isn't a talk about event sourcing. This is a talk about Entity Framework. But event sourcing always comes up as being related to CQRS. So my idea here is start using CQRS because it will unlock the possible capability of doing this stuff in the future. Adding repositories doesn't do that. So let's take a step forward and start looking at how do we do CQRS in Entity Framework. And here's a great library we've started to use called Mediator. So with Mediator, we can define our commands and queries as mediator requests. The application layer just turns to the series of request and response objects. And we also get the ability with Mediator to attach additional behavior around that event handling. So let's take a look at what that looks like. Here is an example of a request. It's called find customers by name. The first thing to point out about it, it's pretty clear what it's for. I've given it a name. Yep, the name is find customers by name. And it's got one parameter, that name. And because I've made that parameter a constructor parameter as well, I can't create an instance of find customers by name without giving it a name string. So what it is incredibly clear how to build this request. Then it also tells you what it returns. It returns this thing called a customers list view model. And that's a view model which is listing some details about some customers. So the idea here, I've created this thing, this really simple class that clearly defines my input, what I put into it, and my output. Then I create a handler class. So the handler class is going to do the work of fetching that data for me. And I'll cover some of the details around here later. But you see we inject in an interface in front of our Northwind DB context, and we have our context code here that's going to get from our database and project it into our view model. And I'll cover selecting and projecting later. So here is a piece of code that handles that. So once again, we have a clear one thing, the definition of it. This is the name of it. Here's what it returns, and here's how I build one. Here is the piece of code that can handle that being sent in. Then finally, this is what my controller looks like once I've taken this on. Because now I no longer have pretty much anything of anything inside my controller. My controller is concerned with taking the request that comes in from the wire. So I've got a request coming in that says find by name and gives me a name. So that will be a URL that triggers that. And then all I do is build this find customers by name request object and send it to Mediator. So I have completely decoupled how that works from the controller, and the controller does no work other than map this incoming request to a handler. So what's great about this is any business logic that's done by the handler behind this thing, I can call that from anything that's capable of building this object. So basically any piece of code that has a string that I think could be a name, I can build a find customers by name query, send it to Mediator, and that will run it. So I could have it in a startup class. I could have it in a console application. It doesn't have to be a web request that triggers this piece of code. So I've made this repeatable unit of work. The other thing that's really clear is the input coming in is this object, and the output coming out is this object. There's no confusion where I'm feeding an object in, and the handler is going to modify the object I gave to it. I'm going to have an input object coming in. I don't expect that to get modified, but I'll get a result output coming out, and there's no side effects. If I want to know what's happened, I just look at the response of that method. I don't have to look at anything else. So it's really clear what I sent in and what I came out. And if I've got an operation that changes 50 things, then I'll expect the result of that operation to return me the 50 things that were changed. So with that in place, let's come back to here, because what I've got here is my interface to my data layer. And once again, it's a dependency injected thing. So the question is, what interface should we use here? And we were talking about repository pattern. I spent a bit of time thinking about what is the simplest interface I could use to just go ahead and use Entity Framework, but still make this an interface dependency that I could override if I wanted to. And this is the interface I came up with. So rather than explicitly listing out all the different types in my application. I've got that in configuration anyway. I've just exposed this dbset generic methods. This context.set of type customer will give me the db set for customers, and context.set of type order will give me the db context for orders. So this really simplifies the interface here. And the drawback of this approach is it's far less discoverable. So if I'm using a context where I've got the things listed out, then it's very discoverable to go context dot, and I'll get a whole bunch of list of things in IntelliSense. Was that a question? Do you want to grab the...
You may answer this a little bit later on, but how do you go about mocking the DB set on that interface?
I will cover that later on, yes. Yeah. So yeah, one thing to point out here is I am still taking a bit of a dependency on Entity Framework. Certainly I'm taking a dependency on DB sets, which comes from Entity Framework, but I've done enough that if I needed to override something, I could create a subclass of DB set and get that to work differently, intercept the commands I wanted, throw not input an exception for the commands I don't. And if I really need to do, it's not clean, but it's a bit of separation. But certainly it's a lot easier than running all those repository classes and putting an abstraction between myself and the data and the database. Another benefit you get from doing this is Entity Framework's improving. There's been a new change recently called IAsync enumerable, which I'll cover later. But this can do IAsync enumerables as well as iQueryables. So you get more for your money than if I just don't use the repository that I'd written 5 years ago and the same repository pattern, then I wouldn't be getting those benefits flow through. So let's take a look at CQRS and EF core and start looking at some read operations. So in read operations, we want to get from the database and get data straight into a view model as quickly as possible and don't track the changes we've made to it. So let's take a look at how we can go about doing that. Here is a query object I've made, slightly more complicated. This has a name search field, and it has some paging fields, a page index and a page size. And it's going to return a view model. So let's take a look at the handler to work with that. So I'm going to start by going context.set. That's fetching me the DB set class. I'm going to call where true. And all that does is turn this into an Entity Framework query, iQueryable, and it's going to contain all the records. But the reason I put where true here is I have started to turn this into an iQueryable. And the key thing with an iQueryable is it doesn't execute against the database until it needs to. So now I've created this iQueryable object, and oh yeah, and the things that will make it execute are things like toList, where it's going to make a list of things, so it's going to have to fetch that from the database, or count, because it's going to count the number of records, or first or default, because it's going to go and load the first record. But until it has to, I can build up this object incrementally and add features, add filters to this object. So I start with a simple iQueryable, and then I can do things like apply filters and apply paging. So for example, apply filters down the bottom here, I can just, if my query object contained a name, it's going to apply that name filter where the name contains the name I said. And if I had some paging values set in, I can use skip and take. So over time, I'm building up a more and more complex query to send into the database. So that's build a query. What can I do with that query? Well, here's a really important step to understand. This .select on the end of the iQueryable here fundamentally changes what goes on with that query. Because if I was to run that query like that without a select, it would go and load those objects as they are and put them in the DB context. Now what I can do is add a .asNoTracking onto that query, and it will tell DB, the entity framework, not to track changes to those entities. So it'll turn the tracking system off. So that's pretty good. But if I do .select on that, I am no longer going to fetch complete entities. I'm going to fetch specifically the fields that I've asked for in this lambda expression. So this block here is called a lambda expression. It's this thing with a fat arrow in front of it. So .select C, that's a reference to the thing I'm selecting. I'm selecting customers. And then I'm going to start projecting that into a view model. And then this maps values from the database into the view model. And because I've got select name, customer ID, and orders, I'm going to fetch just the fields I asked for, rather than the whole thing. So I'm performing a much faster read operation. There's one slight problem with dealing with this though, because how this works is this chunk of code here in yellow is a lambda expression that gets compiled into a link expression, which gets sent to Entity Framework and compiled into a SQL statement. The problem is, the C# code I can put in this yellow block has a much wider and broader reach than the C# code that can successfully compile into SQL statements. So the danger is that I write code in here that Entity Framework can't cope with. And what used to happen with earlier versions of Entity Framework is if Entity Framework couldn't deal with it, it would give up, load the whole table into memory, and then do it all in memory. Now, that's pretty bad. But with EF Core 3 now, it will no longer do that. If it can't do it, it will warn you and won't just automatically fall back to doing it in memory and being slow. The problem with those sort of problems is it works fine when you've got 5 test records. It's not fine at all when you've got 1 million records in production. So, but what can I do if I want to perform an operation in this mapping, this projection, that can't be handled by Entity Framework? Well, here's not what to do. I've seen someone do this. You go early on in the pattern, you just type toList because that fixes it. But what I've done there is I've loaded every single customer and every single order and every single employee record that was linked to one of those orders, and I've loaded them all into memory, and then I can start iterating through and build this small data set that I want. Now, you can sometimes, I'm not advocating for this, you can sometimes get away with it if you've been really good at applying paging and filtering first. So you're filtering it down to 5 records at a time, then you'll get away with it. It's probably fine. If this is an admin screen that 2 people are using, then yeah, just do it, because you've got more important things to spend your time on. But it certainly isn't the right way to do it. So be aware that's what you're doing when you use toList. And as soon as you run toList, whatever the query is in there will be the one that executes. So a better pattern is what I call select anonymous. So what you do is you first pass through a select, and you take fields out of the database pretty much exactly as they are in the database. You don't modify them. Then, once you've got them as they were in the database, you can then load them and then pass them through to a projection that actually does more work and more modifications. So you can convert date times, or work with your, perform operations that can't be done by the database. What I'm finding is more and more stuff works in the database with Entity Framework Core. Used to be that if you wanted to do a time conversion from UTC time to local time, that wouldn't run in Entity Framework. But now it does. So there's more and more stuff is actually being picked up and run. It's getting better. But there'll always be stuff that doesn't work. And this is a fairly simple example. Stuff can blow out really quickly. You have a question?
Are those things mostly implemented on both SQL Server and the Postgres provider, or do you find there's a big difference?
I really like the Postgres provider. I haven't done enough real-world development against it. Postgres is my favorite database, but most of my clients are Microsoft shop. So I am, I can speak for how they work on the Microsoft pattern. I don't know how much difference there is between the two. I've found it's been pretty good in my basic tests of putting data in, putting data out. But when you start dealing with those real-life queries, I haven't got a huge amount of experience with Entity Framework and Postgres. Good question.
Yes. Could you please ask that again? Why did the first example? Why was the first example not able to be run by the Entity Framework?
These codes you've got here are able to run. It's if I had some feature in here that can't compile across.
Okay.
So this example you're seeing here, this does work. Yes. Yeah, but it's easy to put code in here that doesn't. You just make it too complicated, or put in some operation, or any code that can't be run inside the database, then that will fail.
So the Entity Framework might not have been able to build the necessary query.
Yes, it might not be able to build that query. Certainly if I'm pushing a reference to a library that isn't referenced by Entity Framework, like I've made my own extension method to work on the strings, then it won't be able to do it.
Can you test those things using, I don't know, like LinkPad or some querying tool that also uses?
There's certain ways of testing it. I'll come to testing later.
Just a question around what you just said about capabilities that can be done in the database. Just following up on your example about date time conversions.
Yeah.
So entity framework supposedly should work. And again, using your example, you can change out your database provider. An entity framework will work with SQL, Postgres, Oracle, whatever, right?
Yeah.
So in theory, it should provide the same capabilities across all those. So let's say there is are those capabilities that are exposed in entity framework only capabilities that are supported across all database providers, or is it smart enough to offload some of those functions to itself if it can't be done in the database?
That's a really good question, and I'll have to look into that in more detail. My feeling is the idea is that here is the set of things we support, and then we test a provider for that, but the providers are open source, so the entity framework team can't go, well, that's not a provider I'm going to, they don't have a verification process, for example. I know the Postgres team and the Postgres NGP SQL provider have been doing a lot of work, and so that's definitely the first one to do. I don't know much about the state of any other ones, but I can't. There will be bugs where it works in one place and not others. There's no way it can't, and the way to find those is to have more users using them. But I think from my experience of doing basic CRUD operations, the Postgres provider has been pretty awesome. I haven't tried it in anger with some complex queries. So we quickly covered the select then project. Another thing to show you, and a good way of getting data out, is this is a command from AutoMapper called project2. So what this basically does is pretty much the same thing. It'll select as it is from the database, and then automatically use AutoMapper configuration to then map up to the requested view model. Now, AutoMapper is fantastic at mapping between things that are very similar in shape. You have to decide whether it's easier to debug code you've written to copy values across, or debug AutoMapper mappings, because you might find AutoMapper is great for 99% of your application, but the cases where you have to make that configuration for it, is it easier to debug AutoMapper configurations, or is it easier to debug just I've written the code and written the mapping myself? And that's up for you to decide. Certainly I've seen people argue against AutoMapper because it hides code that you can just write yourself, but it can save you running a lot of code. So you've got to weigh up those two considerations. One final thing we've got here, and it's your kind of escape pattern. It's this thing called query type. So it was called query types in EF 2.1 and 2.2, and has now been renamed to has no key. The idea in both of these things, and we'll cover why it has no key, the idea of both of these things is to create read-only models to work with. So it was called query types because you could have context. You had a dbcontext.set to deal with data you could write to. They added the concept of dbcontext.query for just read-only queries you can't change the data. Then they made the decision that, well, actually, there's not much special about these queries. They're just entities that don't have a primary key and therefore can't be mapped. We'll call them has no key. So here's an example of a slightly more complicated thing where I've got customers' most purchased products. So here's a more complex query, but this table, this object, sorry, is the output of a query. I want some customer details and the product details and how many of that product they took. Then what I can do with that is the very first thing at the top there is the has no key configuration line. So that says this is an entity that has no primary key. It will load it in a read-only mode. And then I can say to query and put either a view name in or a full SQL statement in there. So here's an example of the sort of SQL statement where you can write this in link, but I would say once you get to this kind of spot, you're just better off writing it in SQL because you can then use it to open up SQL tools. You can use your query explorers, and in this case, I've got a few inner joins, a group by. There was a problem with group by in Entity Framework Core 1, in that if you had any group by in there at all, it would do it all in memory. So it didn't have proper support for group by at all. That's been fixed, and they've made huge strides to not do stuff in memory anymore. But at some point, you need to be able to jump out and just write a query, and this is your mechanism for doing so, because you can then map up a query directly to an entity to receive the results of that query. Now, before this feature came along, I would have said use Dapper to do that piece of work. because Dapper pretty much does just that. Yeah, and Dapper doesn't have any of that complex entity change tracking stuff. It's just, here's a query, map the results to this object, and away it goes, really super fast. But this kind of just does what Dapper does, with one exception, once you've built that thing, I can treat it like any other context and then add order by skip and takes onto that statement. Because it's SQL, you can take the input of one SQL statement or one SQL statement and then push it into another SQL statement. And so it lets you do this. So this is the
SQL.
Well, it has a new SQL around the SQL where the original statement is SQL in the middle, yeah. Yeah. So pretty powerful stuff. So I can apply paging and filtering and order buying on that complex query. So this is your escape plan, basically, to get out. So the F-core, we've spent a long time looking at the reads. But to make CQRS work well with the F-core, for those read operations, you want to select and project into view models. You can do it with a select statement and use link where you can. Where it gets too complicated, you can use in those query models. But the idea is you do it in a way where you don't fire up the entire entity tracking system. You avoid the change tracking and just get that data out as quickly as possible. Then for your write operations, they're the bits where you've got to have some complex business logic. They're the bits you want to be correct. So in those situations, load complete entities each time, because you might have business logic that's checking things against those entities. And build a unit of work and have all those references properly checked by the entity framework system. So you've got a fast read and a slower write. So in summary, my recommendation is always map those incoming requests to commands and queries in the application layer. And then you've got some choices what to put here. You can use entity framework interfaces or interface-based entity framework and just get on with your life and write some code. You can create a repository layer and achieve true persistence ignorance. That's not a bad thing to do. Like, there's good reasons for doing so. So I'm not saying don't do that, but do what you think you need to do. Or you can create another layer of commands and queries. You can keep that separation of concerns all the way through the stack if that's what's appropriate to you. One more thing I want to show you in this section. This is John P. Smith. He's written a good book on Entity Framework Core. He's also a good blogger. And he's came up with a great example, which to me is proving why CQRS is the answer to go forward. He's written a sample, and this is a picture from his blog from that sample, where he's used CQRS. He's got commands and queries. And what he's done is he's using Entity Framework, and for his commands, he is writing via Entity Framework commands into a SQL database. Then when that write into that SQL database occurs, there's a second process kicks off that projects into a view model. And this view model, this read model, goes into Cosmos DB. So the idea of the read model is it's throwaway. It's not the eventual store of your data. It's there to provide a very fast way of providing certain queries. So say, for example, in your application, everyone's hitting the front page and they're getting a list of products by category. Time and time again, products by category, products by category. Against the SQL database, that'll be a join across a couple of tables. But you take the results of that query, denormalize it, doesn't matter if there's double ups in there, get it in the fastest read model state, put it in that NoSQL database, or put it in 20 NoSQL databases, and have a massive farm of them, so that query serves fast. And then the writes happen fine. Well, how often do you change your product definitions? Like, you know, there'll be 3 or 4 product changes a week because someone's made some content. So fine, they can go in. It doesn't matter if it takes 30 seconds for that to push through to all your read models. But your read models are fast and your SQL is correct. So the key point to make here is if you want to use repository pattern, great, put it there. That's where it belongs. It sits there between the domain model and your SQL statement. But it's putting commands and queries CQS here that allows that next level stuff of separate read models, those extra steps to optimize, allows those to happen. And you don't have to take this all on in an all or nothing approach. We're going to move our entire application to event sourcing and spend the next 2 months building a framework for it. What you can do is just start with what is the biggest pain point. Oh, it's that front page. Make a read model for that front page and get that working first. So it doesn't have to be the entire thing, just make something better with a slightly different architecture. The rest of my stuff's going to be much quicker, so I'll blast through it. So the next thing is testing. So we want to write some tests against our application layer. We want to write unit tests. I'm going to show you XUnit and the EF core in-memory provider. So if you're using repositories or general testing in general, it's a good idea to write mock versions of all this infrastructure and persistence things, so then the unit test can just test their functionality and just receive the data they need for that test to work. But EF core in-memory provider, for me, is a provider for .NET Core that's designed for testing. It's not for runtime. It's there for running unit tests against. And for me, it's not for testing persistence. It's not for testing, I've saved this thing, and then I read it back, and there it is, it's working. What it's for is to give you a quick, powerful mock provider to test the logic inside your application and your command and query handlers. So it's not for testing the database. Write an integration test to test the database. You need to have at least a few. But for testing your code, EF core in-memory provider gives you a much more powerful, faster mock provider than writing all this stuff by hand. It's fast because it's in memory, and it's also allows you to isolate your tests. Because it's in memory and it's fast, you can create basically a new database in memory per test. So you don't get any side effects of, if I write my tests out of order, my tests will fail because I've done an insert before the read that checks it. So let's take a look how we do that. Well, we create a DB context using our DB context options builder. And then we would have said use SQL Server, or we would have said use ng PSQL. We say use in-memory database, and we give our in-memory database a name. If we generate a GUID for that name, then every time we run this to generate a database, it'll be a unique name. If we gave it a fixed name, it'd be the same instance for the lifetime of that application. Then we just new up that database, we put some data in it, and bang, it's good to go. I then have a command that wants to test that we're querying customers or query the filter on them. I can run a test that does that. And if I say context.get customers, I will get that test data for customers. So very easy to write tests against it. And that's basically it for testing. It's really quite easy to go forward. But what I'm going to go a bit further now is EF core performance, because EF core performance has had a bit of a bad rap over the years because of how easy it is to load everything into memory. A problem with EF core performance is generated code is almost never faster than writing SQL by hand, unless you're really bad at writing SQL.
There's a lot of people.
There are. But you use EF core to make that boring CRUD, those create, update, delete operations, quicker and easier to write. You don't want to spend weeks setting up your architecture. And I like going into places and talking to people, working out the domain, drawing lines and boxes on the board. This is a one-to-many, that's a many-to-many. You can very quickly, from that board of one-to-manys and many-to-manys, drop in some classes, hit go, scaffold up your database, and have a working prototype. So that's what Entity Framework is really great for. So when you're talking performance, you should never talk about performance without a reference to something. You need to talk about what is this system for and where does it need to be performant? How many people are going to be using it? What are they going to be doing? Because you could have a really slow system. If it doesn't have enough users anyway, it's fine. Like there's no point spending developer time, which is money, to optimize where optimization is not needed. And so you start performance by measuring your performance against the metric of what you want to achieve. Then you can focus your optimization work for the best business value. You might be able to take 5 seconds off an admin screen, but the admin screen's got 3 users. You might be able to spend the same amount of time taking half a second off the home page, but that's used by 1 million users. Taking that half second off the home page is going to have higher business value than taking 5 seconds off that admin page. So focus that work for where it's needed. And then you also need to do integration tests to reflect the actual and predicted load. And be ready to bypass EF core when you need to. Here's a first super easy win. So we talked about Mediator. Here's an example of a piece of code that you can inject into Mediator to wrap every single Mediator request. So basically, you wire this up to Mediator, and it'll pick this up, and it'll go timer.start, timer.stop, it'll run your request, and if your request took more than 500 milliseconds, it'll make a warning in your logs. So straight away, this takes no time to do. Just cut and paste this one. Steal the one from my sample code there. Put it in your application. you've got a measured metric, go and use your application for a week, come back and look at all the warnings and work out where it's being slow. Start looking at those and work out which ones are important. Straight away, you've started to collect a data-driven approach to your work. Another thing to look at is EF Core and its support for iLogger, because EF Core will log quite a lot if you turn the log levels up. Obviously, if you turn the log levels up way high, it's going to slow everything down, and your production will be slow. But you can take some options. Maybe you come up with a smart way of just logging a certain percentage of requests. But certainly, it's easy to get logs out of Entity Framework, so turn it right up on testing and take a look at what's going on. Integrates well with things like serial logs, seek, and application insights. So good for generating logs, good for collecting those logs, then navigating through those logs. So one thing that's good to do is measure the number of SQL statements executed per command or request. If you're firing a piece of link at Entity Framework and you think it's doing one thing, and you're seeing 5 SQL statements being executed against the server, there's something wrong. Another thing you can do is from the Entity Framework API itself, you can actually tag your query with a name. Then when you look through the logs, you can find those names and actually map up, okay, this particular query was fired by, I've got a whole bunch of stuff going on, and it's only one operation here, something's going on. So I've talked a bit about the performance time bomb. SQL can appear fine when developing against an empty database. I've got 5 test records, everything's great, it's doing table scans for everything, but I can't see because it's on my local machine and it's working. But these problems can surface in production, and you can have lots of upset users. Now, having lots of upset users is better than having no users. Like, if you've got lots of users, then, if you've got lots of users and it's slow because you've got too many users, that's still a good problem to have. Provided they're paying users, of course. If you've got a problem with loads of unpaid users, you've got a problem that tech can't fix. But in generally, those problems can surface in production. It's harder to fix it once it's in production, once you've got a whole user base. So you can't red-green refactor for performance without a failing performance test. So in order to generate a failing performance test, you need to create a test that performs a similar sort of load. You need an infrastructure for testing that looks a lot like production, and you need a size of data set for testing that's as big as production, or as big as your intended production. So how can we do that? Well, that's where this library called Bogus comes in. Bogus is a great library for generating huge amounts of human-friendly test data that's procedurally generated, and then you can use a seed value to make that data set repeatable. So what I mean by that is I can, using a seed value on my generation, I can generate a whole bunch of test data on a server somewhere, generate that same test data on a client, and then use that client to hammer that test system. So I've done this to generate 1 million login records on the server, then generate a client, put that client in containers and spin up 20 containers, all hitting the crap out of that server and seeing how many I can send through. So how do we go about generating some test data? So the first thing we do is we feed it a randomizer seed. So that's the thing that says every time I create a random value using this faker setup, it will generate the same thing for the same input and for the same configuration. Obviously, the configuration changes, then it'll generate different values. But if I have the same configuration and the same seed, it'll procedurally generate the same big data set. Then we come in here, we've got some rules. So we're creating a customer record. So for every record we're going to create a test for, we create a rule for rule. This matches up to the company name. Then we've got this faker object here. Then against the faker object, there's a whole bunch of objects that lets us generate stuff. So f.company lets us generate things by companies. There's a company name. It'll make up a company name. There's a company address. They've got a field called company BS. I'm not quite sure what that's for. I think it's for the mission statement. And against names, you can generate names, initials, full names, and addresses. You can generate, partial addresses, and it's also got a locality setting. So I had a German client, so I set it to German, and it generated German names and German addresses, and they look, like German addresses. In fact, the data looks a little bit like this. Here is some. Here is the output of that very piece of code. You see it didn't map every single field. But the top 2 lines there in that table are from Northwind, and then everything from 78 down is generated data. Now, what this is great for, if you're just generating junk into your database, it's really hard to, when you find a bug, go, oh, there's something wrong with user XYZ57. But if there's something wrong with Boyd Harbour, you can say, hey, there's something wrong with Boyd Harbour across the room. That person will be able to search and find them, and you can start digging into the data. So it's really easy to work with, and you can generate vast amounts of it. So here we are using that to generate a test. And in this case, we've now got an integration test context, because we don't want to run this when we check in our code, because it won't run on our CI/CD pipeline. But we generate a real SQL server. Then we initialize that, migrate it, and put in all the test data. We can then create a whole bunch of fake users and then throw them in the database. You'll notice right about here, I've got a commented out line. This bulk insert operation is available through a library that gives you a kind of bulk inserts for Entity Framework Core. That works great in 2.2, but the version I was using didn't work for 3, just because it hasn't been upgraded for version 3 yet. So I'm doing all my samples in the latest version 3. This library didn't work, but I expect that library to work again very soon when they upgrade a new version. And I mean, that's fairly quick. Customers to add range, but bulk insert bypasses inserts and does, an SQL bulk copy in, and it's hugely fast. Like it's and it sort of bypasses the whole thing. Obviously, that only works with SQL Server because it's using SQL Server bulk copy. But I'm sure you could do something similar if you really needed to with whatever bulk import systems you got in other databases. Got a question?
How does it have a more complex data model with relationships and all that to do with book inserts this kind of way?
Okay, yeah, so the question there was using the bulk inserts when you've got a more complex data model. And basically, bulk inserts bypasses all referential integrity. That's what makes it fast. So the question of how would it handle it? Badly, but not if you insert in the right order. If you create the right related data set and then insert the table with no dependencies first and then the tables around it in the right order, you can very quickly bulk insert, but you need to understand the relationships between the tables you're inserting into. And I mean, you see this when you do restores as well. You'll turn you've got commands you can do on a database to turn all referential integrity off, do a whole bunch of inserts, then try and turn it on and see if it comes up. Yeah. But yes, that doesn't have any magic. Yeah, the bulk insert does not have any magic to sort that stuff out. Add range will sort stuff out for you, and that's why it's a lot slower. Bulk insert doesn't have the checking, but it's fast. You either have correct or fast. It's a trade-off.
The other thing with bulk insert is it switches off database logging while it's doing it. So it makes it incredibly fast.
Yes, it is. It is the speed it takes to take the thing and put it straight into the disk, basically. So for summary on performance, one of the biggest problems, one of the biggest causes of bad performance I've seen in the world isn't to do with Entity Framework, isn't to do with anything other than a developer's been working on a library over here, and a developer on the next layer is kind of using it, and they haven't spoken to each other, and they don't realize that the thing they're calling on the layer down is loading everything into memory, and it's breaking it. Or really simple things like I've written a repository layer here. I saw one client where they had a app name setting that was global for the entire application, but then it was also the root of all their permissions. And every time something was coming in, every request would query this one string from the database like 5 to 10 times for every single request. So all we had to do was just put a cache in there on that one thing, and suddenly the number of database hits went right down. So that wasn't a problem with Entity Framework. It was looking at the code, piecing together the story, and realizing they were doing work they didn't need to do. So it's those logical errors. Measure and prioritize your optimization efforts. You're never going to make everything perfect. So, everything needs to be good enough for the task it's made for, and then find the bits that need to be fast and optimize those. You can then got a whole bunch of options for optimizing your queries. You can rewrite your link. You can write handwritten SQL when you need to, like be ready to jump out. And finally, one of the most effective ways to speed up most applications is just caching the stuff that can be cached. Like think about how often it changes. How long can that cache be? Sometimes a cache of a second or 5 seconds can massively speed things up. And a very easy way of getting good caching is once again this CQRS pattern. Because your read models are separated, you can create a CQRS application layer that queries a database, keeps a cache for however long you want, and then that sped it up.
I find that one of the things that's really good for communicating that to a developer is to say the fastest database query is no query at all.
That's right, yes. Yeah, you're quite right. Like databases, on the scheme of things, are slow. Compared to in-memory C#, databases are incredibly slow. Because to make a database query, you've got to start by opening a connection. Now that connection might be pulled, but it's still fetching a connection resource. Then you've got to send a string down that connection resource, and that requires network traffic, so it's an I/O blocking operation. That goes to a database. If you're lucky, the database has seen that query recently, and a lot of the table there, but it's still a whole series of steps being performed by a whole bunch of different systems, where if it's just already in memory, it's just to fetch it and send it. It's better than an order of magnitude faster to return something from cache, like maybe a factor of 100 or so.
Or faster.
Yeah, or faster, 100 to 1,000, I'd say. So finally, a quick run through of some of my favourite features of what's new in Entity Framework cores. Not everything, but some of my highlights. One of the biggest things is the link improvements, more stuff. And remember that highlighted big yellow blob of link, which gets turned into a query? More stuff works when you put it in SQL there. That's the way to look at it. Just more stuff works in more cases. And also, we're getting rid of that horrible bomb, which was client-side execution of stuff. I'd much rather it failed when I'm looking at it than looks like it works, but then has performance problems down in production. Cosmos DB support. This is going to be really useful for doing things like CQRS as well. Like Cosmos DB is a great answer for providing that read model support. So there's a provider for Cosmos DB, and because of that, some fundamental changes are happening in the guts of Entity Framework. They're breaking it up, and because before that, at that point, it was assumed everything was going into a relational database. But Cosmos DB is not a relational database. It's more like a lookup key store, document DB, that happens to support SQL as one of its interfaces. But to do that, they've actually started breaking up, and now a lot of the relational logic has moved into a new package called Microsoft Entity Framework Core.relational. And the Cosmos DB provider will enable most, see I've highlighted most there, EF core features. So I think it's going to be good for most operations. Like it's going to, and certainly for things like building a read model where you're not going to be querying it, you're going to be, here's the data for this query, hold on to that, and then I'll have a whole bunch of web farms sending that query in when it needs to happen. It's going to make that stuff very fast. C#8 support. We touched on this when I mentioned one reason for not creating your own abstraction around Entity Framework is you're not going to get fun new features. So this fun new feature is called iasync enumerable, and it's part of the C#8. Let's try and explain this one. Way back in the .NET 3.5 days, we had this new concept coming along with collections called the yield operation. And the point of the yield operation was I could have a collection that sends out values as it has them, and I can consume that collection kind of asynchronously as a stream. Now, the whole async kind of await stuff is all about non-blocking I/O operations. So what you can do is you have a task, which is that thing that's waiting for an I/O operation to happen. So I'm waiting for a database query to run, for example. When that database query is finished, that task will then pick up the await bit and carry on. So if I want to use a standard async command with a huge database command, and I want to load a huge bunch of data, if I just use async, I'll wait until that whole thing is finished running and then get that million records. Iasync enumerable joins the two together. So it joins the concept of an async operation to perform the initial query. Then the thing I'll get back implements iasync enumerable, so it will start feeding me values as they're available, not waiting for the entire query to finish running. So I can do an async command to fetch the data and then start streaming that thing through. So if I want to create a request that wants to handle 1 million records, it will start getting me the first value, and I can then plumb that stream through all the way to my output and start streaming the data out as it's read. And so I don't have to have 1 million records in memory. I can batch that up one record at a time, and it's sort of streaming kind of model. So very cool stuff. And yeah, if you were writing a repository pattern, you wouldn't have iasync enumerable, but you get it by default if you're just talking straight to DB sets. EF 6.3 on .NET Core. So a lot of people have applications that they're looking after, and some of those applications, can you believe it? They're more than 2 years old. So what are those people going to do? That's right. You can rewrite, but you know, some of these are more than 2 years old, and they've been written on top of EF 6.3, and EF Core is not the same as 6.3. There are subtle differences that if you had to go through in a whole code base and unpick them, it's going to be hard. So until now, those people are slightly stuck. I can't move forward to .NET Core and take advantage of all the new .NET Core stuff, certainly the web APIs, they're way better, because I'm stuck on 6.3 as my persistence mechanism. Well, now because you will be able to put 6.3 on top of .NET Core, I can have a .NET Core web API and all the features there, but then still have EF 6.3 running in that same process and don't have to rewrite everything. So that's going to let you take advantage of all those API controllers where you have one controller class for all the different types of controllers rather than fundamental different plumbing for API-based stuff versus MVC-based stuff, which is what you had just before we switched to .NET Core. And all that dependency injection configuration stuff as well. So you get all the benefits, but still keep your EF 6.3. So that's going to be a good migration story. Entity Framework Core is no longer part of the ASP.NET Core shared framework. So what happens here? What does that mean? When .NET Core first came out, it was really light, had not much with it. So the idea was to make it really explicit. We'll ship you this empty project template. If you want to do anything with it, you need to download those APIs yourself and add the NuGet packages, which was very clear. Everyone knew what they would, everyone knew exactly what had been put into their project because they put it by hand. But everyone complained because it was hard. You had to spend all your time working out what combination of dependencies I need. So they came up with the idea of coming up with this ASP.NET Core.all mega package that included loads of stuff. So all we had to do was just open up a new .NET Core project and bang, ASP.NET Core.all was there, and you had all this stuff all embedded in, and everyone complained because it was too big. It contained a load of stuff. It even contained stuff that wasn't from Microsoft, like Redis cache engines and stuff. It was a kitchen sink approach, putting everything in. Now, while they did this, they improved some tree shaking stuff around. When you compile it, it shakes it down. But people complain because it's too much stuff. So we're seeing an ongoing refinement from hardly anything to everything and the kitchen sink to a smaller amount of stuff. What that does mean is that the EF Core tools are no longer available by default. You've got to install them. You've got to do the .NET Tools add command to bring the EF tools into the command line. What it also means, though, is for all Entity Framework users, it'll be the same experience, where the way it was is if you're using SQL Server, it's already bundled in, you don't have to do anything. Where you're using anything that isn't SQL Server, you've got to do extra work. Now everyone has the same steps because they've got to go and install Entity Framework by hand and put in the provider they want to use. So there's one path to follow for all the users. Backing fields. So there's a couple of things I want to talk to you now about various improvements in getting Entity Framework to map a more complicated domain model. So the idea of backing fields is instead of mapping to public getters and setters, when you're mapping from an entity to your database, you can actually write directly to private fields on that object. So you're free to put business logic on those getters and setters. You might have a set command that when you change a value in an order item, it will then trigger the recalculation of the order total on the parent above. So doing that with classic Entity Framework Core was hard because Entity Framework Core would write to all those fields. You can put not mapped attributes on, but if you start writing to backing fields instead, those are private field properties, it'll write to those instead of writing to the public get set properties. So it gives you more freedom in having more complex domain models. Owned entities and collections. The idea here are you can have parent and child objects where it makes no sense to load the parent object without its children. Say, for example, an order object, and the order has order items, and the total in the order object is calculated based on the presence of the order items. In that situation, it makes no sense to load the order object without its items because it won't work properly. So you can say in Entity Framework that the items are an owned collection and then Entity Framework will never give you an instance of an order without its related order items. So once again, features that make Entity Framework better at mapping complex domain models to your database and kind of giving you some semantic control. So that was some of my highlights of the best things of what's new. There's a load of stuff of what's new, and the docs are amazing on this. There's lots and lots of little subtle breaking changes that are kind of too small and esoteric to go into in a talk, but the documentation has been fantastic. And in fact, it's the whole documentation story with Microsoft has been amazing in recent times. And Entity Framework Core is one of those examples. Just go to the docs. It's very well written. It's very clear. And not only does it show the what, it's very good at explaining the why as well. So we looked at a whole bunch of stuff. This turned out to be a long talk. We looked at introducing Entity Framework Core and the fundamental concepts. And I really want you to walk away understanding how Entity Framework tracks changes to entities that it works with, and the subtle difference around that update command. The fact that it doesn't mean I'm going to update the database, it means I'm taking a detached object and I'm putting it in my DB context. We looked at the basic using and configuring, how you can really quickly get Entity Framework to work, but then also the reasons, the problems you get from that really simplistic approach, and how to take a step back. Then we looked at clean architecture and how to put Entity Framework into a clean architecture context. And we discussed the pros and cons of, do I use a repository pattern, or do I take some kind of more direct dependency on Entity Framework? And how CQRS is actually a much more powerful abstraction to put into your application at an earlier level before you then go and talk about what your database layer is. And finally, we looked at testing, EF core performance, and then what's new in Entity Framework. A couple more things. Adam already brought this up, but they've got the .NET Core Superpowers tool. So I think I will finish by saying thank you for listening. Any more questions before we finish up? Yep, grab the microphone.
Yeah, just schema migrations in EF Core, as like using the features available there as opposed to tools like DBApp or Roundhouse or any of those other tools.
Yes, your questions on schema migrations. The schema migrations are a brilliant feature. I've got a great part of the talk on it. I just couldn't fit it in. There's too much stuff. Yep, all right. I'll run over really quickly. Yeah, thank you very much. Thank you. I had to get this down to 45 minutes to do DDD Melbourne. So, that's the only time I've only got anywhere near 45 minutes. But then I had to really hammer through it. It's hard. You've got to kind of rein it all in, and you've got a few seconds per slide. But I do have some code here.
We're going to hand out some emails. Tonight's free. The cost is some good comments. Can be harsh. He needs it. Sharpen him up.
Okay, so let's talk about migrations. So I have an entity here, and my entity here is a customer, and this is Northwind, which is from the 90s. So in the 90s, there was no such thing as Twitter. So there was no Twitter data. So I've put an extra field here to put the customer's Twitter handle. So to make a migration, I go and make a change to my schema. I've added a Twitter field. Then I run some commands. I run .NET EF migrations add and give it a name, Twitter, and that will generate for me a migration. And the migration looks something like this. You see I've got two ones here, one for Microsoft, one for Postgres, and they both have two versions of the migrations. And if I look at the migration here, I've got one here called customer Twitter. So what it does automatically from just that change happening to that entity model is it'll recognize that I've got a new Twitter value, and will create this kind of DSL, domain specific language for schema updates with add column, give it a name, give it a table, very readable stuff. So that's cool. How the hell does that work? If you look behind the scenes on these migrations, you will see behind every single migration, there's this thing called a designer file. And this designer file contains a whole bunch of generated code. Now, way back in the EF6 days, this was a big, ugly binary blob of data. There was no way to read it. But now in EF Core, it's this beautiful, readable, fluent syntax format. So what happens is, the version of this from the most recent migration is written into this thing called the DB context model snapshot. So when I say add migrations, it will look through the current configuration of all my classes, all the configurations against those classes, and compare it to the data that's in the last snapshot. So it doesn't read the database at all to work out what's changed. It takes that snapshot of data and then compares it to the new snapshot of what it's got, and then from there generates this migration class. Then from this migration class, let's go back to that one, I've got a few options. I can, at startup with the application, apply those migrations directly to the database, and the database itself will have a table to keep track of which migrations have run. Or I can use this to generate SQL and send that SQL to my DBA who wants to vet everything. So there's a few options there. You can also, one thing to consider with having the application apply its own migrations is if you want to do a farm of servers, they might fight over who gets to upgrade. So at that point, it's a good idea to move the migrations into a deployment time process that a console program runs. Also, that means you can run your schema changes with a higher set of privileges than your runtime web application gets. So you have a little console program that runs during deployment, that runs with schema changing privileges. Your application can run with scaled down privileges. Another thing to consider is this code is the scaffolded code. You are free to make changes here, and in fact, you can also just write, I think it's migration builder. Yeah. You can run migration builder.sql and put any arbitrary SQL you want in that process, or you can write your own of these things. Basically, this is a scaffolded thing. What writing your own code here is useful for is if you're migrating a column type. Because generally to migrate a column type, you need to create a column, copy the data across, and then delete the old column. Well, this won't generate that copy the data across operation because it looks at your schema. It doesn't realize you want to copy from one table to the other, but you can write that into this process here. So you're free to write as much code as you want into here, but be careful you don't get into the state where you've written so much stuff, your database is way out of sync with your actual schema configuration. So I'd say generate first, and only use this for simple operations where you're not modifying your schema as such, you're just migrating data inside that schema. You've also got some options, as well as writing migrations in here. You can also, you've got an operation to migrate data. So there's a seeding mechanism that now works its way into the migration system and inserts data or removes data with the migrations in sync, where previously you would had a seeding system where it'd run all the migrations and then apply a seeding system at the end. It was hard to, if you had seed data that was in sync with a different part of your application, you could get yourself into a situation where you had data that worked in history as you worked up, but a new developer coming in, it'd apply all the migrations and not have seeding in sync and not work properly. Now that seeding system actually comes in with the migrations, and the seed generate data you generate becomes part of that migration, and so the migrations and the seed data for those migrations stay in sync. So yeah, that's the migration system. So it's vastly improved. Like this whole readability of this thing now is much easier. You can actually look and say, what do you think it's actually there? And you look at it and you can see what they think the configuration is, and then you can go back to your, you can also, if you don't like what this has done, delete it, go back, change the configurations, scaffold it again. And all of these migrations also have an up and down version, so you can roll back. Obviously, you can't undo data that was put in there. If you do a drop on your database, you've dropped the data, but you can run the schema changes back and forth through time until you get it right.
And the tooling for that works just as well on Mac and Linux. You don't really need Visual Studio to get those features you were talking about there? Or?
Yeah, it's a very good point. Yeah, these features all work from the .NET EF command, and so it works, it just uses the .NET to run. So yeah, we've gone on the days where you needed the, there was a time when the way to run EF migrations was to launch them from inside a special PowerShell console that was there for package management. Even at the time, we were thinking, this isn't right. This isn't how console development works. It was just the first time there was a good console support for anything inside Visual Studio. And so finally, there being a good console support for Visual Studio, they started to use it. It was a weird decision. It kind of worked, but now it's properly working as its own console. Now, the PowerShell options still do exist, but everyone uses the .NET EF because that's, like you say, cross-platform, and it works fine, yeah. I've also seen some posts around new tools coming in, so we're starting to see kind of migration tools coming in and richer tools for your mappings, but I like reading the code to see my mappings. I don't need to see pretty pictures spread out. I'll draw pictures and then make it in code. I don't want to do the other way around. Every now and then you can generate pictures from your code, but it's not a thing I really care about. Any other questions? Any other questions? I'm going to pass down the...
Sorry, this is a newbie question. You said that lazy loading actually tend to encounter the N+1 problem.
Yep.
Does this problem also occur in eager loading?
Oh yeah, so eager loading is a complete bypass of N+1, because with eager loading, you say up front, I want you to load this customer, these orders, and these order items, and you say it up front, and it'll go and load them all. So it's, I mean, with eager loading, you are definitely doing a lot of SQL work, because you're getting all the data, but it won't be the N+1 problem, because you're not using lazy loading at that point. You're saying up front, load it all. So eager loading definitely isn't an N+1 problem. Oh, that's right. Yes, with eager loading, your problem might be performance. If you kind of think, I might need it, so I'll load it just in case, you might be loading data you don't need. So yeah, the problem there, it's always a trade-off. Eager loading is safer against the N+1 problem. You're going to have it in just one batch of SQL work. But yeah, the risk is you're loading stuff you don't need yet. So really the best way to handle it is, for me, it's that CQRS approach and making commands for a certain thing. I think a lot of the problems with things like lazy loading and things like eager loading is when you have a piece of functionality here that gets a bunch of data and you reuse it in different contexts. So in, I've getting a customer for this context and getting a customer for this context, and sometimes I need to have more details about the customer and sometimes I don't. I would prefer to split out into separate commands and load just the data I need to fulfill that command, and then if there's a different use case, have a different load process to load just the data for that command. Then there's no crosstalk between those two operations, and everything's loading what it needs for that specific use case, and we don't get this crosstalk or things that break because I'm changing it over here, but it's also been linked to over here. No problem. Okay, looks like there's no more questions, so thank you very much.